Okay, it looks like we're live. So, welcome back. Today I'm going to be continuing to work. No, I'm going to be starting a new thing. I'm going to be working on this Turing machine, right? So, I don't know a whole lot about Turing machines, but I was reading on them, and it seemed interesting, right? So I thought I would try to implement an interpreter for one. Essentially, is what it would be. An emulator, I suppose you could say. Um, yeah. So Turing machine, right? So there's this good explanation right here, sort of how it works. I'm writing in C. Right, so Turing machine mathematically models a machine that mechanically operates on a tape. So it's like a tape, right? You can imagine that. And each tape has symbols. So I'm just going to be using zeros and ones, so it's going to be represented in binary. So it can read and write one at a time using a tape head. So it's like a pointer at it, right? And operation is fully determined by a finite set of elementary instructions, such as in state 42, if the symbol seen is 0, write a 1. Symbol seen is 1, change to state 17. So you have sort of like a list of states here. List of different states, and then depending on what the symbol is at the current head, right, the current pointer, then you'll either change the symbol or leave it the same, and then you change to a different state, right? If it's 0, write a 1 and change state 6, right? So that can go on forever, and you can write basically very complex programs, things like that. Okay, hey Stam, how you doing? What is up? I still have the 10-second delay on as well, so if there is a delay, that is why. What is up, Stam? Let's see. Yeah, so that's sort of all there is to it. So you have like a tape. Essentially it'll expand infinitely to the right. And there is a boundary on the left, right? But I'm just gonna do it with a finite, like a set size to start, and then we can expand that later. But yeah, so there's like a tape and then the pointer to it. The delay is like 1 hour. Well, because there is still like the set delay, so it's probably like 15 to 20 seconds. Yeah. It seems to be working fine right now, though, so that's good. Used linked list recently. Nice, nice. And how'd that go? But yeah, basically, well, it'll be entirely binary, so it'll just be zeros and ones. And then we'll just move the head based on that. So I'm gonna try some things out. So let's see. I have a .c here. Yeah, basically, let's just get started. So I'll make a structure, and this will be for the machine, right? So this is like the Turing machine. So we need a few different things. We're gonna have a list of instructions. Well, let's see. What do you think? We're gonna have the data, right? So we'll have that. So data is just gonna be all these booleans. Data. Whoops. We need that, and we also need std. It's gonna capitalize that. So yeah. So the data, it's gonna be just an array. So let's have the size here. Data size. Had to make the iterative trait and broke your mental health. Was this for the evolution simulator? Right. The data, so that's going to be the zeros and ones, right? So that's why I'm using boolean, because it's either true or false. So 0 or 1. Let's see. And then basically we need the instructions. Let's make an instruction. Keep capitalizing the first one. It's awful. Oh, for shard. I see. So what was the linked list for? Like, what was the use case of it? So the instruction, we have to look at what the current pointer is. So actually, we're doing that here as well. We need the which is like the head. We'll call it the head, because that'll be what it's pointing at, right? And then we'll have the instruction, and that will have a few different things. So we'll need a boolean. Well, do we need? Well, we'll need the direction. So the direction then is going to go. We'll actually need 2 of them. So I'm going to do yes and no, right? And you'll see why we'll need that in a second. No idea. Okay, interesting. How's Rust coming, or not Rust? How's Shard coming along, by the way? I haven't looked into the Discord or anything at all in a long time. So yeah, so we'll need that for an enum, right? Direction. So this will have we'll have left, which will equal -1, right? To move to the left, and then we'll have stay equals 0, so it'll just move none, and right, which is 1, right? So that'll be, we'll just sort of add to the head, depending on what it is, right? So if it's yes, so we'll have a boolean, and this will be the value, right? The expected value, essentially. So if this is true, then we do the yes one. If it's false, then we do the no one. Code base is super complex and overly so. No comments, no structure. Terrible. Does not sound great. Horrible. Awful. Right, and then we need the value that we're gonna write as well. Yeah, so just be bool right, yes, and then we'll have bool right no. Right. So if this is the case, then we'll write this value. If it's not the case, then we'll write this value. I think that makes sense. Not gonna lie, not gonna lie. They've already gone through a rewrite, right? Because as far as I know, before they had like some of it structured. I don't know about how much necessarily, but it was at least to like a parsing stage or an AST, something like that. But then they rewrote it, and they rewrote it poorly again. Right, so we'll stick with that for now. And let's make something. Let's see. We need some more stuff in the machine, but let's initialize the machine. So let's do machine random. That's right. We'll have that, and we'll pass a machine here, right? So I will initialize the machine. So we'll do machine. We'll just initialize it with 0. Data size. Let's just call it size. Sorry, yes, that's sort of the size of the machine. Again, it should expand essentially infinitely, but we'll have a set size for now. You hurt your ego against this project because you were not familiar with language design. So machine.size equal, let's do 8 to start. Yeah, then we'll randomize it. So we'll randomize the data, right? So I'll make this function. Right, you don't need to take it that way because the code is just awful. That's fair. And let's see, machine. Let's loop over the size, right? We'll also need an initialize to allocate the whole thing, right? Or we could just allocate it there. It doesn't matter. Machine size. Let's plus. You don't have experience with languages, programming languages. Yeah. Yeah. Data I equals. So let's see. I think I can randomize it. Right? So we can do like random divided by 2, so that'll cap it at 0, 1, right? And we'll set the seed to that, right? Just to randomize it all. So we'll need timeout h. Let's see. So that'll randomize the whole thing. Yeah, and then we'll just obviously initialize it. So machine data equals malloc. Well, since we're initializing the whole thing, we can do malloc. And bool, right? That's what it is. Times size. Machine size. Okay, and that should allocate the whole thing. So we have the array, and we can initialize that. So if we just change this size, it'll change the whole thing. Okay, so that's sort of the machine stuff. That would be I'll keep it bunched together like that. And then the instructions, so I'll make instruction let's do it like this. And let's see, so we can create them, right? So expect. So let's say we expect the value to be 0, and then we would change it to 1, right? And the direction that we would go is right. If it is not, then we'll keep it at 0. Or no, if it's 1, then we'll change to 0. Yeah, yeah. That's what it'd be, and we move right as well. And we also need the next one, right? So we need two of them. So next no and next yes. Right. So there's some ways that this could be compacted, but we'll get to that. I want it to be kind of clear before I get into that. You guys are cool, but don't explain anything on how the code works, and think you know what they made out without any assistance in the form of structure, right? No comments is okay for the evolution project of Kano, but when you have a ton of people working on it, it's unacceptable. Yeah, I've been working on commenting Kano as well, because I sort of realized it's not very maintainable without knowing what's going on. I mean, it's still not great, but yeah. Yeah, I think so. That's quite unfortunate, though. Okay, yeah, so the next, direction, yeah, and then the next value we'll go to, so Julio Rats followed, thank you. It was an interesting sound. I think it was different. I don't know. But let's see. So the next one is going to be the index in this array, essentially is what we'll do. So this one will be 0, and then we'll have one that's 1, right? So that'll be, our side will be null, so the last one will be 1. Right. I don't know if this program will necessarily work. I do have one that's like an incrementer, but we'll get to that. But yes, that's the index. Otherwise, we'll just go back to the same one. Alright, so that's the next. So then we need the actual thing that interprets it. Hello, how you doing? What is up? I do apologize. There is a slight delay on the stream because I'm having internet issues. So if it takes me a second to reply to the chat, that is why. Let's see. I might turn it off for the next stream, the delay, but we'll see. Right, so this is sort of like interpret, right? So machine interpret, or right, so we want to execute an instruction on the machine. So we'll need the machine as well as the instruction, and we'll just do it like that. So yeah, we'll just pass a pointer to whatever index. So this is going to actually return the index of the one. So let's see, if the machine data and then machine head, right? So the head is the pointer to it. So we need to actually set that. We'll set it to 0 by default. I guess it will be set to 0 by default with this, so we're all good with that. The thing is, okay, I'm doing pretty well. If that equals expected, then this is the expected box. This is like the yes box. Otherwise, we have the no. Well, actually, I don't even need an else, I don't think, because I'm going to use returns. So in this case, we'll return inst next no, and this one, right? That's kind of a weird naming scheme, but that's all right. Inst next yes will be returned here. Sorry for your English. You're from another country. And you don't speak English natively. That's all good. That's all good. I only speak English, so yeah, doing better than me for sure. Right. So then we need to write. So we want to set machine data, machine head equal to inst write yes. Explain what the virtual machine I'm in C is for. Okay. There's a bit of stuff here, so I need to open a few tabs. I'll do it over here, so I have that. Basically, so the virtual machine, right? This one that I made. I'm assuming this is what you're talking about. This one. Tim, right? I made it. It's stack based, right? There is registers, but they're not used, so I'm gonna get rid of them. But it's stack based, where you can basically push stuff on the stack and move things from the stack, and it all works from there. So there's also a memory segment, which you can write to, but you can only interact with it through the stack, so like pointers on the stack and stuff. So I made that, and then I made it to eventually create a language on top of it, and that's what I'm doing with KanoScript. So that is what KanoScript is for. So it compiles into the bytecode for the virtual machine. Like the virtual machine, if I go in here, it can read the bytecode and write to it as well. In here, I can see there's like read. It's all pretty much in one file, but let's see, there is like a read program from file. So it just sort of opens it up, and then it reads it based on what segment of the bytecode it is at. It's not super organized, the bytecode, but yeah, that's basically that's what it is. Yeah. Okay, and then let's see. Yeah, and then what I'm working on now is just a Turing machine emulator, I guess you could say. Yeah, but then we need to change the head as well. So machine head plus equals. Okay, yes. Plus equals the direction. Yeah, so dir yes. And then here we do plus equals dir no, right? So basically, the way that would work is if it's left, that's the direction, it'll subtract 1, so it'll move to the left, right? If it's stay, it'll be 0, and if it's right, it'll move by 1. So that's just, that makes it quite simple. Let's see, what else? So we need to do this, this part as well. So you, write, something like that. Okay, so here's the instructions. So then we could, this would need to be in a loop, right? So while inst's, current is not equal null, then we'll continue here, and we'll set current equal to machine execute. That's a pointer to the machine, and then a pointer to inst's current, right? And then yeah, that's basically it. So we do that. And at the end, it'll just exit here. So this is basically the halting state, right? Which you'll see in some of these, which we'll get to. I'll get to like actual programs and stuff once it's working. Let's see. Yeah, so that's the direction move. So this is, I could comment it sort of to show. So expected value, and then true, direction if true, value false, direction if false, and then we also have the next if false, right? So we have the next if true as well. Yeah, it's something like that. It's kind of confusing. I could maybe make that a bit better, but that basically explains it now. So we have the expected value, which is the first one. Also, the highlighting is a little messed up. The value, if that's true, so would be 1. The direction, if it's true, which is right. And then the next value, if true, is 1. Right, so that's the index right here. So that'd be null. Instructions to keep the head still. Yeah. So there is stay, which basically, instead of when we write it left, it'll just stay, right? Which you can just set it here. So just have to do stay. And that would, in that branch, it would keep it in the same place. But I'm not using that yet. Yeah, I have a program that I'm going to try, but I'm not there yet. But yeah, so 1, that's like the halting state. And then 0 is just repeat this one, essentially. So let me see if this compiles at all. Let's see. Expected something before that, so I think I forgot a semicolon. And then... Let's see, that doesn't work. Hang on. I need to think about how to do that. So we need to check if it's null, but... I can't just check the value and see if it's 0, because that doesn't work. So I need to check if... Well, okay, I can just check if current is greater than the size, right? Greater than or equal to. And I think it has to be size minus 1, right? Because the size is... Well, no, that's the size of that, so that's not right. So I need, I actually need the size of this. So this is the size of inst count, right? Equals size of inst divided by size of insts. Right. So that'll be this if it is greater than or equal to that inst count. Right. I think I have to do minus 1. Okay. Yeah, so let me see that now. It does compile. There's not really a program. So we need a way to print. We'll just print the current state of the data, right? So we'll do print machine. Machine print, right? I'm going to keep a consistent naming scheme, right? Machine. So we'll just pass that, and we'll just iterate over it. Machine size, and then we'll print it out. So we'll print f. Let's see. So basically just the current state. So that, and it's gonna be like look like a linked list sort of. Machine data I. And at the end we will print a new line. I could just put 0 everywhere. Okay. And it's supposed to be void, yeah. And we'll just print it at the start of each iteration, I think. Okay. Run this. And it does not print. Why is it not print? I think maybe we don't do negative. What is the size then? 2. Yeah, so that's not it. So it's not printing it out. Why does it not? Right, so obviously it's not calling that at all. I don't know what happened. Hang on. Current is 0, right? Less than 8. That's my bad. I messed that up. Did it the wrong way. Okay. Now it goes forever. Because, yeah, I think I do need the minus 1. That's why I did that. It still goes forever, because it never reaches the end state. So... Right. So, the current actually here. Current is... We'll have another comment. Well, we don't have the code actually. Could that be in the machine? We have the head. Run up the head. Oh, that's probably a good idea. Anyways, that's sort of where we're pointing at the moment. Yeah, and that just goes very high. So we need to actually check if it is at that point. What is current though? I want to see. It was 1 and 0. Why would it go? I see. That's not right. Right. Then it does end. Okay. Let me try something. So I have over here, let me see if I can find. Right, I just want to, it is a program. Right, 0. Into 0. Yeah, okay. Something like that. Trying to make like an incrementer, right? Putting it out there and then at the end, so we can see both times. Right, so I want to make a binary incrementer. It's going to be where the left is the least significant bit, because that's easier to sort of work with in this environment, right? So I think, let me see. So, let's make it with 3. Zero, 0, 1, right? So that would be that'd be 4, right? And then this becomes 5. Yeah, so that does work, right? So that is what I thought. Right, because you read it sort of the other way. Where this is the least significant. I mean the most significant. I said it the wrong way. Yeah, that's the most significant. So it'd be like flipped, basically. From what you would be used to. Usually reading it. Yeah, and I can put it into a thing as well. But let me try that again, actually. Because it should randomize. Yeah. Well, no, it didn't randomize. It was the same. Oh, but that time it did. Okay. Yeah, and I think that one doesn't work because... okay, that's actually kind of interesting. So it just sets it all to 0. Because it tried to set the last one, but it... Yeah, that's why if it would expand infinitely, right? 101, that again. 001. 011. Yeah, so you can see it increments it, right? So you could imagine that would be 7. And then it becomes 8. Yeah. And you can say it to 8, right? So it's like a byte. And look at it. There's the trailing thing, but that's okay. Let me see. I can get a binary thing. Yes, right? Just because I'm not very good. Not very good with that. So yeah, we read it this way. So it'd be 11010101. So that is 213, right? And then it becomes at the end. So the end is what matters. 11010110. 214. So it does increment. That is good. Yeah, so that's just an incrementer for that. And it's actually very simple. It's just sort of one thing, and there's 2 possible branches. If it is, if the value is 0, then we set it to 1, and we move to the right. Yeah, and then we end it, actually. We move the head to the right, but then we end it, so it doesn't actually matter. It doesn't matter which way we move. But otherwise, if it's 1, we set it to 0, and we move to the right. Yeah, and that's pretty much it. So that's all they need to make a binary incrementer. Right. And yeah, it's just, you can see how it would be easier to work with it if you were doing it that way. So I can commit that. Right. An emulator or whatever, but that's fine. Let's see. So, yeah, you could write more complex programs. I'm not really familiar with such programs, but there's some, I think, on the Wikipedia that we can read through. Let me just make sure it's all good. I probably want to go through it and sort of simplify it, because we have a lot of unnecessary stuff here, right? Like repetition and things. So, could submit push-ups, but you're in a good mood today. Well, I don't mind the push-ups, you know, if you want to do them. I did hit chest today, though, so would be extra tiring. Yeah, but there's basically just 2 branches. So if that's the case, then we set this off and move. So it's actually really simple. At least this way. If you get more values, it gets a bit more complex, right? So probably could do something with arrays to make it more possible values. Because we only have two because we have binary. Last gem when? What do you mean? What does that mean? Okay. Yeah, maybe we'll read through this some. So, this is what it consists of. So maybe I should work on making it expand infinitely to the right, because that's how it's supposed to be. Where it goes just as far as it needs to. We also need boundary checking if you move to the left. Right. So maybe if it equals 0, then we need to we cannot move left. When was your last workout? It was this morning. Oh, let's see. A tape divided into cells, one next to the other. Each cell contains a symbol from some finite alphabet. Right, so we just have 0 and 1. Alphabet contains a special blank symbol, which is 0, yeah. And one or more other symbols. Tape is assumed to be arbitrarily extendable to the left and right. Okay, so it can go to the left sometime. Always supply as much tape as it needs for its computation. Cells that have not been written before are assumed to be filled with a blank symbol. Lol, yes indeed. In some models, the tape has left n marked with a special symbol. Right, yeah, so it, that's where I got where it could stop at the end. But I guess it could extend infinitely both ways. And the head just starts at whatever point. A head that can read and write symbols on the tape and move to the tape left and right, and only one cell at a time. Some models, the head moves and the tape is stationary. Right. Yes, that is sort of how this one works. Yeah, okay. State register that stores state of a Turing machine, one of finitely many. Among these is a special start state, with which it's initialized. All right. Replace the state of mind a person performing computations would ordinarily be in. Interesting. Finite table of instructions, given state that the machine is currently in, and the symbol it is reading on the tape. The symbol currently under the head tells the machine to do the following in sequence, right? Either write or erase a symbol, right? That's what we got, and then move the head, and then assume the same state or a new state as prescribed, right? Okay. Yeah. So if it was the same state, then we just put the same index, right? So the states are based on indexes here, rather than like names. Which seems to be sort of similar to how this works, like state 17. Okay. Yeah, and there's all this here as well. Right, you can write complex stuff with it. I think you can write a Turing machine interpreter. Right, hang on, let me see. I think it's called Universal or something. Yeah, Universal. There we go. A single machine which can be used to compute any computable sequence. If the machine U is supplied with the tape on the beginning. Right. Okay, something like that. Yeah, there's a lot of interesting stuff with it. But yeah, let me try to clean up the code a bit, and then I can try to write some sort of program. I'll have to think about that though. So I think this is probably fine how that is set up. Direction as well, so it's really this. So we have two states. Let's make just a struct for that to start. So so this is like basically the state, right? The new state. So yeah, and then next. Right, so that's what we have. And then we could put the state here. So state, this is yes, and then we could have a state no. And that removes all of these. So we have to change the code to get it to work, but then it does that, and then we can go here and set inst yes dot right. Dot dir, and then it's dot next, and here as well. It's no. Push-ups. All right. 10 push-ups. 10 push-ups. Add to. All good. All good. Done. Okay. Don't actually need to. Yeah, I got it. Got it. Okay. Let's see. No direction, and then no, yeah. Then we have to change how we initialize it. I should probably make a function for this to create each instruction. Or a macro. It was a joke. Bruh. Right. So this one stays the same, the value, but then the other two are different. Maybe they can just be like this, though. And I think that works all the same. I'm changing back to 3 because I can tell the 3s. Yeah, okay, perfect. So that that does work. And that's already a little bit nicer. But yeah, obviously, if you were to extend it to use a larger thing, you'd have to keep extending that. So I need to probably use an array. We'll get to that though. Right, because then you could use letters and actually write out things not in binary, because you need a lot more space if it's binary. Perhaps you could have hexadecimal values. Right. I can make a macro. Should I do that? Something to initialize the instructions. Well, that's probably fine. I feel like current should be part of the machine though as well. No, that's the current instruction. We should probably have the instructions in the machine. Well, should they be separate? Like maybe we need a greater thing, which contains everything. A greater strap, like the whole program. So I'd have the machine. This can be a pointer to it, and then the instructions, and then the current as well. Right, and then if I initialize it with 0 and set program, right, and we can initialize this and then set program dot right there. That's machine current, or machine the program. Alright, let's see, does that compile? Does not. Yeah, because now this is already a pointer to it. Right. Let's actually, let's do this. Can I do, well, let's do that. And that's it. And then use it like that, okay. Here as well. Program has nothing called ints. What's it called? I'll call it ints. Turn go for real. Love turn. Yeah, 0 becomes 1. Yeah, okay, so that does work. It still works. Right, and it's more structured, I guess. Could this be simplified, perhaps? Let's see, I'm not sure how to pronounce that. Yeah, I'm not sure, and I don't want to mess it up very bad, but thank you for following. I appreciate it. We're cooking indeed. Yeah, well, really it was Turing that was cooking, but we're programming. That's true, that's true. Let's see, so randomize. So we could also not randomize it. Instead it's to set values, but I feel like the randomizing makes it more interesting. It'd be cool if you could input something as well. Right, so read input from the user, like maybe specify the size. The size, and then oops, I bumped my desk. The size, and maybe what else would you set? Like if you make it set the instructions, that's basically just making a programming language for the Turing machine, which I don't necessarily want to do that now. There'd be some stuff you'd have to do. But let's see. So I think I could make this more readable. Expected. Right. So this is the expected value. That's the value that you would set it to if it's true. This is like the true block. That's the direction you'll move, and then that is the next index that you go to. And this is if it's false, what it'll do in the same order. Right. Trying to think. So what else is in here, right? Is there some examples of a let me look actually. Right. Well actually let me look at this. So this is incrementing a binary number. So I'm not sure if which way it reads it from. But that's basically right. We do that where we have the left is the least significant rather than the right, which it usually would be. Because that makes it simpler because it moves from left to right. So let me look. Okay, so this seems to be the same way. From right to left. At first, our pointer is at the leftmost side. Shift the pointer to the rightmost side. Okay, so it puts it on the right. And then I'm going to skip all zeros at once until we get a blank. Now move the pointer from left to right. Right. We get the first digit 1, then we change all the 1s to... Alright. See, that's a more complicated way to do it. Because it's different. Yeah. Okay, so this is doing it a traditional way with a rightmost one. Yeah, I just read it wrong. So it's to the right until it gets to the end. So this would have to be a finite size. It's the end. Wait, I don't know that we can do that because we don't have a way to check necessarily that we're at the end. Let me find. I want to find something with good examples. Let's see, I'll just look through here. Is this gonna be flashbang? Yeah. For addition, let's see. I need to learn how to read this. Because there's a lot of stuff that goes on. Let's see. Step 1, convert 0 into X. Yeah, so we need more symbols for that. But are all ones or all zeros? Right, so okay, so that's how you separate the numbers, I see. That's how they do it here to add them. Right. So ours is more limiting than that at the moment. Put it into X and go to step 2. With C, convert it into blank. See, all right, there's a lot of Turing machine stuff here. Can I just, whoops, no? Not a good UI. What is TOC? Let's say here. Type 0 language, is that what it is? Right, I want one that has 2 states. Is this flashbang site? Yeah. Why is every website in light mode? So I just need to find a good thing. Is this? It's a little bit. Make a Turing machine only using the preprocessor. I mean, you could do that, right? This is kind of flashbang, but that's fine. That could be an interesting thing to do, for sure. That's interesting. Yeah, now I got to see preprocessor. Turing machine. We have that. This can be flashbang. No, okay, it's not. Yeah, so is there a Turing machine? Oh, it is not Turing complete. So you can't make one then, right? Wait, what is this? In the C preprocessor. Interesting. Now I'm just getting distracted, but that's pretty cool. I should try that. Make something in there. I need to get better at it, though. A lot of stuff. Turing machine. Okay. Put a code for a Turing machine. Right. Okay. Interesting. Yeah. Okay, that was unrelated, but not entirely. This kind of flashbang. Alright, let me go back in here. I just remembered, yeah, I need to set the boundaries. I read that and need to do that. So if it's greater than the size, then we need to just terminate, right? So set the state to termination. I don't really have a way to just set it to that. If we include the count, right? So if we set, I realize this could just pass the program now, but that's fine. But then we need to pass it to each one. That's fine. Okay, let's try that. And then we can, not sure, but after what I've seen done with map macros, pretty sure recursion is possible. Yeah, never really tried it, but it doesn't seem off limits at first glance. Yeah. Yeah, I think you could. We saw that thing where it was the interpreter, and it had a Turing machine. I don't know. I didn't really look into it, but it said it was limited in some ways, but it seems to be possible. Oh yeah, I need to add that here. Right, so I just passed the struct, but that's fine. So if than or equal to int count, then we need to just no, it's greater than or equal to size. Then we need to break, right? So we need to set int. We just return count, right? And that'll just end it instantly, basically. If we go too far to the left as well, then we need to do that. So at the end, we really need to check that. So I'm thinking we could change how this works. Right, well that will already make it unable to go too far there. To the right, but then to the left, if we move to the left, and it's already 0, we don't really have a way to check that. So at the head, no, we need to check if it's equal to 0, but then we don't have that. Right, because this, we just add to it. If it's less than that. Right, check it like this, but that's not very nice. Machine head equals 0 and check that, that's not very nice though. It's 0 and then oh, so basically if it's -1, because that's the only other thing it could be, but that would work, right? Then it can't go to the left and then underflow, and it can't overflow. So it's sort of constrained. Yeah, so it's easy to read. I'm not gonna. Yeah, there we go. Right. Then it is constrained at least. Or it should be. What's that? Right. I'm gonna do that. Make it larger. How large? Let's do 16. Yeah, so there's the head, where the head is pointing at. Which index, basically. So yeah, this one just iterates this one. And then it ends. It could go through many, if it's like a bunch of zeros lined up. It's a bunch of ones lined up, I guess, actually. Yeah. Oh, shoot. Yeah, so there we go. So it had to go through all of those before it did that. Yeah, okay. Let's make it very large, and then we can get many iterations. There's a better chance. It's actually kind of too large, because then it's harder to read. Set it all to 1. Yeah, let me try that. Go at 16, but then set them to 1 on the randomize right here. Then at the end, set set it to 0. And then we'll go through the whole thing. Yeah, because it's like that, so it just iterates that. Right. Yeah, I'm gonna do that every time because it's the same one. Yeah. Right. I'm trying to find more. No, I'm just gonna here. Machine. What does this have? Yeah. I don't want that. Let me actually commit quickly. Let's see. Let me change back to random because that's better. Yeah, there we go. Yeah, so I don't know how extensive this is gonna get. Like, if I um want to extend it, right? So then could have more, like a larger alphabet, and perhaps user input. Like, I don't know about making a whole language, but if you had user input where there's certain things, and then the user can define the parameters to write a program, sort of, could be interesting. I mean, not all today, obviously, but I work on making it infinite, though. Basically just as large as it needs to be. But, right, so you need to, if you use a dynamic array, could just append to it as necessary, but like, how does that work with incrementing a binary number, right? Hey, Tobbs, how you doing? What is up? That, yeah. Example, let's see. Bit flashbang, yes. I think this one needs to, yeah. Okay. I could turn on the dark mode thing, but I don't want to. Tons of tops, true. Doing pretty well. I'm doing well as well. Well as well, yes. Thank you for asking. Turing machine, let's see this. Step. Am I doing wrong? No. Tons of times would be 1 times because you weigh a ton, bruh. Not really, not really. But it's tons, right? So even if you weighed a ton, it'd have to be at least 2. Okay. Finite state machine. Yeah, I need to read more on that. If read is 0, red is 0, and write 1, move right. Else write 0. How do you know? Turing machine today, yes. Yeah, so I have one here. So it's quite simple. It's less than 100 lines right now. But here's a simple, it's like a binary incrementer. It's just sort of flipped, right? So it's the left bit is the least significant, because that makes it easier to count when you're moving from left to right. Yeah, so basically, just how the interaction with it works. This is the expected number. Don't worry about the highlighting. Don't worry about that. This is the expected number, so 0, right? If it is 0, then execute this one, right? So set the value to 1, move to the right, and then go to 2, which is the next state, which in this case is halt, essentially. Otherwise, if it is 1, set it to 0, move to the right, and then repeat, basically. What exactly is a Turing machine? Right here, I go here, right, let's see, what is the best? Mathematical model of computation describing an abstract machine that manipulates symbols on a strip of tape according to a table of rules. Yeah, okay, so that's, whoops, I pressed on that. I can't even pronounce that, okay. But I think a better one here. So, Turing machine mathematically models a machine that mechanically operates on a tape. On this tape are symbols, so there's a tape. My OBS did something for some reason. Okay, you have a tape. What the heck? You have a tape, okay. And it has some sort of symbols on it. So in my case, it's just binary, so it's 0 or 1. And it can read and write to it. And you have a head, which is basically the pointer for where it's at. So you can imagine the tape extending infinitely. And then the head only points at one element of the tape. And then depending on what that element value is, it can change that element and it can move left or right, and then it also goes to the next instruction or state. Wiki to German, caught lacking. What the heck? But yeah, so basically on the tape are symbols, which the machine can read and write, one at a time using a tape head. Operation is fully determined by a finite set of elementary instructions, such as in state 42. If it's 0, then write a 1. If it's 1, then change it to state 17. Right, so basically there's just a series of states that it transfers to, which modifies the data in the tape, yeah, to just sort of execute something. So in my case, it's incrementing a binary number. So let me change it to be smaller so it's a bit down. 5. Kind of hurts. That's not right. Right. So like this. So the left is the least significant. So it's sort of reversed of how you would normally see it. But yeah. So basically, it does this. It'll set that to 0, and then does that. So that'll increment it by 1. That should be 3 because then I can't translate it. Right. So in this case, that would be 5. And then it becomes 6 because this is 4 and then 2, so yeah, 6. So it increments it by 1. Yeah, just sort of in the simplest way possible. And yeah, so the code, it looks like this, where we have an array. Where's the array? Up here. This is the data. So this is like the tape. I guess it should be called tape. And there is a set size. This one is not infinite. And then the head is what it's pointing at the moment. And then depending on what the value is, we change it. Either we can change it based on, yeah, if it's true or false, basically. Right. Yes, that's what we have here. So if it's the expected one, then we set the data to what we expected, that value, and then we also move the head, right or left, depending on what it is at, and then we return the value. And that's basically the whole logic of the machine. The rest is just the instructions or the states. Yeah, hopefully that makes sense. Yes, I'm not very familiar with them, so I can't just write a program in it. I need to copy someone else's. Pretty cool, yes indeed. Medium. Don't want a light mode website. What's the practical use? Well, I don't know if they're necessarily practically used really for anything, but it's basically just it's a machine, and you can make pretty much any program in it, right? Can make an interpreter for a Turing machine as well. So it's sort of like a virtual machine in that sense, where you're emulating or simulating a physical Turing machine. So it has the same use that a virtual machine would have. That would try to simulate an existing, or simulate a CPU. But in this case, it's a Turing machine. Let's go back up here. Let's look at one. Let's look at a C one. Basically, yeah, I'm just doing it just to play around and learn more about them. Like, there's sort of a theoretical element to it that is interesting. Yeah, I was looking at some here. Set the string. I should try this. So we need C and Python. Right, 156 lines, okay. Current state, input symbol, movement, new state. Right, okay. That's a similar layout, but it's not exactly the same. Because in the symbol, nothing practical in 2024. True, the only practical thing is JavaScript. Everyone knows this. Input symbol, new symbol, and movement are single characters. Right, is there an example? Oops. That's like the whole program. So non-deterministic is Python. Oops. To define 1,000 states, you unlock the golden Turing machine skin. True, very true. And what about 10,000? 10,000 states. It's light mode. Hang on, let me change to dark mode. Hang on. Flashbang. I want to read this one. There we go. Now it is not. It's not dark anymore. I'm not light. Let's see. So, let's see how it is. So we predefine fully declare them. It's just the header file. Okay. Direction left and right. So there's no stay. Boolean as well. Platinum skin, but that's very rare. That makes sense. Yeah, 10,000 is quite a bit. What level did Alan Turing get to, though? The inventor. What skin does he get? What's above platinum? I don't know. Interesting. So that's the symbol. I guess I could use that. Use that for this. Right. I'm just thinking of, ways to expand it based on this. Because, yeah, I don't know a whole lot about how they work, just from what I read on Wikipedia, basically. That is unnecessary. Exit failure. When do they exit? What is the case where you would do that? Machine current. What is current? Oh, that's the state. Okay. An inventor can give himself any skin he wants, but he stayed humble and did not once in his writings flex about it. Wow. Very humble. Using raw pointer for performance in the evolution part. Bruh. How much performance do you need? Raw pointer best. True, true. Do not obey. Okay. Save program. Love save program. Except when you don't want it to be saved. When I write Rust, I just wrap everything in unsave. And pretend it's C. Fancy C. Memory safety is for people who don't know what they're doing. Very true, very true. People who know what they're doing are not afraid of seg faults. Or memory leaks. Yeah, okay, that's it. Yeah. Very common way to declare constants, enums. Yeah. Right, okay, so that's just kind of I'm just reading through this now. I'm not even talking. Not even talking anymore. Malloc return void. Casting it, bruh. Okay. I thought you're not supposed to do that in C. Raw pointers in Rust. Okay. Raw pointers. I haven't looked at that at all. You know, I don't use Rust, so. Okay. Raw pointer. This is gonna be a raw pointer. Common ways to create raw pointers. Put the star there. Why is that funny? Which changes prevent the program from exiting if a segfault occurs. Very true, very true. I'm confused about what it... Because it's unsafe, that's why it's funny. Wait, does it have to be in unsafe? Drop box from raw my speed. Kind of funny just to read it like that. Pointer. Right. Yes. Very true. Literally use... Wait, you can use malloc? Yo, no way. Calling the libc? Every language is just a wrapper of C, you know? Are you doing this? Are you using libc in Rust? That's my favorite way to use Rust, is just use C. For real, very true. Is this? That is. Flashbang? No. Why not? No, 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 no. No, 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 no. Flashbang. I'm gonna see a bigger example that it's not. Rust syntax best. I don't know about that. Just sidetracking now, but that's okay. Cast it to usize. Bruh. Array as pointer. Interesting, okay. Browser automatically turns white background. Yes, I do have that. But I have it disabled to do it automatically because it gets really slow when it does that. So I have to enable it for each site, and I don't want to enable it for everyone. So I just go through websites until I find ones that aren't. But yeah, I have it. That's why I Stack Overflow over there. On certain sites, I have it just enabled all the time. Yes, sir. Priver.dev. Oh, this is somebody's personal. Let's see. Rust pointer. Let's see. 8 different ad blockers enabled, and your browser still works. I have 2 ad blockers, I guess. Because I have the Brave one. But then that didn't work. I don't remember. It was something it didn't work on. So I got uBlock as well. Also, I have the special YouTube one, so that if something breaks, then it'll work there. They're good to sneak by the borrow check, bro. References, yeah, raw pointers. There we go. Yeah, so it's just, and you have to unsafe to dereference it. Interesting. You can just do that in C without unsafe. It's just all unsafe. So that's why C is better, right? Ad blocking equals freedom. Very true. Librable, GigaChat, uBlock. uBlock is good. Right. All right. I was trying to find an example of a program. Okay, this is probably really cool. Hang on, I'm gonna enable Dark Reader over here, so I can look at this because I want to see this. All right. Browser works with YouTube, Spotify, Twitch, all the movie sites. You don't know what you did, but it works, bro. Why is it? Oops. Why is it like that? Like what? What? What's that about? What year is this? It seems to be very old. 2008. Okay, well that makes sense then. Oh, I guess it shows 2008 here. Wait, is this it? Hang on, I gotta try that. Hang on. Hold up. Oh shoot, it's C++. Okay. Need C string with it? Alright, it's gonna make it longer though. Segfault, very nice. IOStream, Ayo, C++ mention. Yeah, it did not work. I think I might be stupid though. Yeah, so this is C++. Is there one that's not? C++, C++. They seem to all be C++. Yeah, this is interesting though. So I don't know how it works. It might be outdated. Might have to use older version of C++. I'll just skip it. Okay. Yeah. Okay. Maybe what I'll do is have the user supply the starting. That could be interesting. The starting state. I'll just have it like this. You could do like that. Then you could choose the number you want to increment. Richard Stallman said, "Don't do C++, kids." Very true. Very true. Yeah, let's do that. Let's see if it's then we'll just do that. Do it like that. Otherwise, so some stuff is going to move out. But if it's 2, then we want to take the second one and use that as the starting state. Yeah. Okay. That should work. But it's not going to be very safe, but that's okay. Iterate over that, and we'll set the starting state to that. So really, we're just randomizing, and that's the only, and the size is going to be different. So essentially, get the size. Strlen built-in, it is a function from string.h. And then it is. But no, it's not built in. I can make one, but I'm not going to, so. And just set, I need to allocate it as well, though. Equals, I think mine is a string, right? So mine is 0 then. 3.8, yeah, you have to include 3.h, yes. It's built into the standard library, but it's not built into C. Set that. An internal, yeah. Just libc. Libc. Let's see. So this is in second. This can be moved out here. The allocating is actually the same. But we need to do it twice, so let's do that. We'll do it like that. Macro that determines the length of string literals. Yeah. Well, okay. What's the emoji about, though? Do you like my C code in the last video? Let's see. I don't really remember it. Let me see which one. Yeah, I watched it 4 days ago. Hang on. Let me find the C code. Yeah, here's the C code. Okay. Hang on. C code. Interface when they add that macro to C25. When is C25? I haven't heard about that. Let's see. Create the vector. Right. But I don't know that I would use int necessarily for the length and capacity, but you can, right? Turn that. Right. Allocate it. Right, that's fine. Yeah, I mean, it seems fine. It's not very much. And you have more? Oh, yeah. Okay, it keeps going. Right, then you just multiply the length by 2. Okay. Reallocate it. Okay. Yeah, you can do length plus plus as well in here. Then you can just get rid of that one, but that doesn't matter, really. You try to clone Zoding or want some uniqueness. Well, I mean, some of it's unique. A lot of it is a clone, though. Yeah, for sure. I thought you saw something conceptually not C-esque. Yeah, not using at least unsigned int. Yeah. Yeah, usually you would want to use unsigned for that, but... Right, okay. Right. Zoning cost by true. Yeah, I mean, it looks fine. Other than the unsigned. Okay. What was I doing? It's right. So I think this is pretty much the same. The instructions. So all that can be out here. It's really just initializing it, right? I think I messed up the for loop. I always see who's a rustation and who isn't. Thought it was the same with C. Well, C is pretty simple. There we go. Okay. Yes, that does work. Alright, very cool. Yes, you just have to provide it backwards, but... Unless you do usize for the length and capacity. Yeah, usually I use size type, right? which is just U64. Let me check or whatever if there's extra, but that doesn't matter. So yeah, I could write a README as well. I gotta go pretty soon though. Not really a big README, but start or clone it and then sage. There, and that's it. Rip, did it go out? No. What is rip? Yeah, that's it. Build it and run. Okay, that works. And it can be randomized. How can I add that? Yeah. Okay, I need to come up with a better name for it. Something. Some kind of name. Yeah. I gotta go rip, bruh. Running with me, imagine. Programs are only intended for those who can tell what it does from the name. Very true. Very based as well. GigaChat. Yeah, but I didn't explain anything in the README, so it's fine. Just how to use it. Oh, then I gotta go rip. Okay, I understand what you're saying now. Yeah. Let's see. I don't need that open anymore. Yeah. So I'll probably do another video. I'll read some more about it. Or another stream. And try to extend it, right? So I want it to extend infinitely to the right, so I'll need to think about how to do that. At least to the right. Perhaps both directions as well, I'm not sure. You know, infinitely, not actually infinite, though. Least floated README, true. Yeah, so that'd be cool. And then some way for the user to perhaps input things. Like a very simple language, basically. Just a very, very close to it, where you have certain arguments, and then you write it. Also to extend it to be not just binary. Yeah, so that's sort of the goals. The goals, right? I am American, yes. Where are you going at this time? What does that mean? But I'm American. Stam is not American. In Europe, it is 22:40. Yeah, it's not that late here. I cannot work. Hang on. There we go. Yeah, and then I can actually put the line here. It doesn't have to fail. Okay. Never been good with accents or anything like that. Me neither. I have to go to bed at 5 p.m. True, yes. Go to bed at 5 p.m. and then wake up at 3 a.m. That's what I do, for sure. That's a long time, actually. Long time to sleep. Yes, also this game is interpreting like that. Okay, that kind of feels like the screen. Yeah. Let me make that. GigaChat grind set for sure. Yeah, so I do have to go, though. I'm going not to go to bed, actually. That's a joke. Not actually go to bed. 5 times a day. Well, at least, yeah. Well, not necessarily the gym. You know, you go to the gym once or twice, but then you do the other workouts. You know, like you go for a jog, or you do 10,000 push-ups. Hey, wait. This is what I do. This is what I do 5 times a day. Yeah, 100 push-ups, 100 sit-ups, 100 air squats, and then a 6.2 mile run. Yeah. There's been at 3 p.m. Very true. I'm in bed right now, actually. I'm sleeping. Early morning at 12 p.m. True. Yeah. Okay, yeah. I'm going to go, though. Not to bed. Okay, yeah. So thank you guys for watching, and I'll see you next time. Bye.